It's base times height over 2. Across from the 45s, we label those with x's. And then what do you label across from the 90? X squared root of 2. Now, if there's a number there, remember to put an equals between it and the label. I already had someone come in this morning that wrote down 6 equals square root of 2 or something like that. So it is x square root of 2, and you need to make sure you have an equals between it and the label. Okay, I'm actually going to solve this just on my little sticky, but if you guys need to put it on your paper, that's fine. So I'm going to solve that equation real quick. So 6 equals x square root of 2. What would you do to get x by itself? We're going to divide both sides by square root of 2, and then those cross out. That's really my answer. It's just it's not in simplest radical form. So you can't have that square root down in the denominator, so I'm going to get rid of him. Will it bother you if I write it up here like that? So I'm going to multiply by whatever's in the denominator over itself, and then I'm going to multiply straight across, straight across. So what's 6 times square root of 2? 6 square root of 2. And then in the denominator, what's square root of 2 times square root of 2? Just a 2. And then I can do one more thing. I can divide the 6 and 2 and get a 3. So 3 square root of 2 is my x. And that's what I needed. I needed to know what my x was so I could work. We had an ugly lesson yesterday, so we're just going over the homework problems like in full detail. Okay, so our little x is 3 square root of 2. So this guy is a 3 square root of 2, and this guy is a 3 square root of 2. And in case you don't know, wherever the right angle is, that's where the base and the height are. The base and height are always attached together with that right angle. So the 3 square root of 2 down here is my base. The 3 square root of 2 here is my height. So I'm going to take 3 square root of 2 times 3 square root of 2 over 2. Okay. In the numerator, I'm going to multiply the outside numbers first. So what's 3 times 2? I'm sorry, what's 3 times 3? 9. Then I'm going to multiply the square roots of 2. What's square roots of 2 times square root of 2? Just a 2. So I've got a 9 times 2. And then I have the over 2. What would that be? 9. It'd be 18 over 2, which would be a 9. And that's the area of this triangle. Questions with that? Okay, now perimeter is the distance around a shape. So it's this side plus this side plus this side. Now, what was this side originally? A 6. The problem is I can't add a 6 with these guys because they have square roots of 2 behind them. So I've got this 6 here that I'm just going to tag on, but these two I can add together. What's 3 square root of 2 plus 3 square root of 2?
6 square root of 2, so your perimeter would be 6 plus 6 square root of 2.
Yes, either 6 plus 6 square root of 2 or 6 square root of 2 plus 6. I don't care how you write it. So either the 6 first and then the plus 6 square root of 2 or the 6 square root of 2 plus 6. Doesn't really matter. And anytime you have to rationalize that darn denominator, the FFU problems, those are always the hardest ones. If you don't have to do that in the problem, then the problem's much easier. Okay. Number 7 is kind of like the number 13 that I did that I blinked on yesterday. Where are you? I tried to make it so big so you guys could see well. Okay, what shape are we looking at?
Trapezoid.
A trapezoid. So I'm going to go height times base 1 plus base 2 over 2. And then I'm just going to start plugging in things I know. This looks weird. I've had people think it's a 48 square root of 3. That really kind of doesn't make much sense. This is a 408 square root of 3. It just doesn't look like it because that 8 is like pushed off and it looks a little more bolded than the 40. But the area is 408 square root of 3. So I'm going to put that right here in the A. So 408 square root of 3 equals, and then I'm going to start plugging in what I know on the other side. Do we know the height? No, so I'm just going to keep the h there, and we're going to solve for him. Do I know both bases? Okay, instead of showing all my work, let's just add them in our heads, because it tells me to add base 1 to base 2. So what do you get when you add your bases? A 20. So when I add my bases, I get a 20, and then I recopy all over 2. So all I'm going to do is pop my 408 square root of 3 over 1, making a proportion, and then I'm going to solve by cross multiplying. So what do you get? Okay, keeping this in simplest radical form. When you multiply this diagonal, the only thing you're going to multiply is the 2 and the 408. What do you get if you multiply the 2 and the 408? So 816, and then you just recopy the square root of 3. And then when you multiply the other diagonal, what's 20h times 1? 20h. Okay, to get Mr. H by himself, what would you do? So I would divide both sides by 20. Now the only thing you're going to divide by 20 is the 8/16. So what do you get if you take 8/16 and divide that by 20? 40.8, and then I just recopy the square root of 3, and that's your height. And we're done. How'd you feel about that one? They all have a lot of steps. How many of you got it right? A couple of you? Okay. What shape is this? This is a parallelogram. Top and bottom are parallel, sides are parallel. Okay, what's our formula for area of a parallelogram? This one specifically says base times height. Okay, so the height is straight up and down, and it connects to the base. Do you agree that this base down here is the same length as this top one up here? Okay, so I know the base is 11, because this is going to be the same as this up here. So the base is 11. I just need to work on finding the height. And it is a 5. So just to go through it real quick, we've got a 45, 45, 90 triangle happening. What goes across from the 45s? Okay, so X here, and across from the 90? I got to make this slightly smaller. Okay, so I label it with an x squared root of 2. Don't forget to put an equals between it. Now, without me doing anything, can you tell just by looking at this equation, what should x be? 5. X should be a 5. If these two are supposed to be equal and look the same, then this needs to be a 5. That way, 5 square root of 2 equals 5 square root of 2. Does everybody see it, that the x should be a 5? Does anybody need me to actually solve it mathematically to prove that to you? We're okay? Okay, so if I solve that, I do get that x is 5. So this little guy down here is a 5, and this little guy right here is a 5, which is the height. So I now know that the height of the parallelogram is 5, and what's 11 times 5? 55. I don't know if we were really supposed to find perimeter with this shape or not, but I'm just going to do it real quick. The directions weren't very clear on this assignment in general. So when I go to find perimeter, I'm going to add up all the sides. I'm going to start adding these two sides because they're like terms. What do you get if you add the 11 and the 11? Okay, so perimeter will be 22 plus, and then this is a 5 square root of 2, and this is a 5 square root of 2. So if you add 5 square root of 2 to 5 square root of 2? 10 square root of 2. And there's your perimeter in simplest radical form. Okay, these next two, I only found area. Once again, the directions weren't very good. It only talks about problem number 9 here, and it says find the area for problem number 9. So I just found the area on 11 and 12. You want to start with the easier one or the harder one? The harder one? Let's get it out of the way? Okay, so let's do 11. What shape is he? A trapezoid. So I'm going to take the height again, times base 1 plus base 2 over 2. You have that formula memorized yet? No? It's probably just me because I do it 6 times a day and I say it so many times in a day. It's just like I could never forget ever. Okay, we are missing a bunch of things. I know the top base is a 9. I do not know the whole bottom base, so I'm going to work on that. And I don't know the height. So I'm just going to find some stuff and then I'll start plugging in. What kind of triangle do we have? 30, 60, 90. Okay, what goes across from the 30? X. What goes across from the 60? And it's only talking about from here to here. So that's x squared root of 3. And then what goes across from the 90? 2x. Now because there's a number there, I need to put an equals between it and the 2x label. Now this one's much easier to solve. What do you get when you solve this equation for x? 4, because you would divide both sides by 2. And if you divided both sides by 2, you're going to get 4. Okay, so if x is 4, then this is a 4. And what's this? 4 square root of 3. Now, can you tell me what's this?
9 plus 4 square root of 3.
Yes, the whole thing will be 9 plus 4 square root of 3. And then from here to here is 9 because from here to here was a 9. Okay, we have everything we need to know. So what's the height? 4 is the height. Now, I could do a couple things here. When I go to add these bases, I could go ahead and just add the like terms now and then attach this on, or I could specifically go 9 plus 4 square root of 3. Or are you okay if I go ahead and add these two together right now? So I could, if I add these two together, I'm going to get a 18. And then I still have this piece of the base down here, which is 4 square root of 3 that I need to add on. Now, those of you I was helping this morning, I tried to show like all my work. So right here, I put 9 plus 4 square root of 3. But that would make an 18 anyway. Okay, I could do a couple things. I could distribute the 4 first and then divide by 2. Or I could reduce the 4 over 2 first and then distribute that. What do you think you'd rather see? Distribute the 4? Okay. So what's 4 times 18? 72. And then when I distribute here, I only take the 4 times the 4. So, good, 16 square root of 3. That square root of 3 just recopies, and then I just recopy the all over 2. And then at this point, I'm just going to divide both of these by 2 since they can. What's 72 divided by 2? 36. And then 16 divided by 2 is 8, so 8 square root of 3. And there he is. How many of you got that one? Courtney, you're rocking it.
Thanks.
Whoop, whoop. I'm not making fun of you. You look like you're scared of me right now.
No, I'm not having an early morning.
I'm sorry. Do you need a hug?
That's what I was about to say. Not right now.
Okay. Well, let me know. I gave Faith a squeeze yesterday. I don't think it helped her either, but I did it anyway. Aw, Faith. All right, number 12. Can you tell what shape it is?
Kite.
It's a kite. These two sides are congruent. These two sides are congruent, so this is a kite. And it's diagonal 1 times diagonal 2 over 2. This one is actually pretty easy. What is this diagonal right here? 28. Okay, one diagonal down. I need to figure out that other diagonal and divide by 2. Now, to figure out that other diagonal, it's not so bad because it comes out sweet. In the rhombus, in the kite, in the square, you got 90-degree angles in the center. So I need to do what right here? Pythagorean theorem. So it's going to go x squared plus 8 squared is 17 squared. I want to see if you guys can give me an answer without me writing anything down. Did somebody say something?
15.
Oh, 15. Are you okay? I choked on my spit yesterday during one of my classes. I thought I was never going to get over it. Oh my gosh. Gross, I know. Did we get 15? Now, if this wouldn't have come out pretty, then you wouldn't have liked the problem. But because it came out nice and sweet, then that's okay. So if this piece is a 15, what's this one right here? And then how long is this whole diagonal? 30. Now that's easy to work out. So take a moment and take 28 times 30 and divide by 2. And what do you get? 420. Ooh. Really?
Let's look more back to that earlier.
It's Arbor Day. Everybody should point the tree.
Yeah. Okay, keep going.
Okay. Do you still feel like it's like completely awful?
Yes. Yeah. We should just skip this whole entire.
No, we're not skipping it because, like I said, you're going to see it for weeks. We do volume and surface area next, and it's in the volume and surface area. And the lesson I have for you on Monday, oh, he's fun. It's finding area of a regular polygon.
Why do you hate us?
And we have a new formula. It's not me, it's just the curriculum. And these little shapes are all going to have 30, 60, 90s or 45, 45, 90 triangles in them too. Okay, so I guess I'll just do a mixture of problems, and then I'm going to have you guys try some. We still have our quiz tomorrow. Now, the first 3 problems on the quiz, I'm not worried about whatsoever with you, because we practiced some like them yesterday, and we practiced some like them the day before. They just involved Pythagorean theorem, and you guys were fine. Now, the last 2 problems on the quiz, that's more like what we did yesterday and what we're about to like re-practice today, where you'll see maybe a 30, 60, 90 in there or something. So, when I come to a problem like them, I'll let you know. Let's just look at the front page. Oh, sorry, I'm going to shrink this down. This is page 11. You can make a note card. Definitely. I would, if I were you, especially if you don't know the labels. This right here that I highlighted in green and purple, these would be good to have on your note card. And then, of course, the very front page of your packet had more formulas on it. So if you felt like you needed some of these formulas that are on the front page of your packet that aren't on this one, then you could put that on there too. But like right now, that would definitely be good to have on there. I'm so sorry. What did you say?
We can make a note card for the quiz.
Yes, Jake. That's what I was trying to explain. Yes, you can make a note card for the quiz, and then you keep it. You hang on to it, and you'll get to use it for the test. And then when the test rolls around, it'll be extra credit. Yes. You may have a note card. Please make one. And if you want to put, examples on there, put examples on there. I mean, I don't care. Is there something on the front page that jumps out at you?
Triangle.
Okay, well, which triangle, Jake?
The Illuminati. It's the first one.
Well, okay. But the first one is not equilateral because there's not a tick mark on this side. Okay, it is an isosceles triangle. So, okay, let's just do it real quick. It's only asking for area. And what's your formula for area? 1/2 base times height, or base times height divided by 2. Okay, do you know what the base is? The base is 12. Right. And what's the height? 8. The height is straight up and down. It always connects to the base. So it's just 12 times 8 over 2. That's easy. What's that? 48. Now, if I wanted to step the problem up a notch, then I would ask for perimeter. And if I asked for perimeter, you would add 12 to whatever this is to whatever this is. And in order to find this side, what would you have to do? Pythagorean theorem. And what would it be from here to here? 6. So you would do 6 squared plus 8 squared is blank squared. Do you know what it is? No. It's a 10. Do you remember me mentioning the 6, 8, 10 triangle? Now, if you don't? Of all people, Cheyenne, I did not expect that from you. Okay, so if you didn't know, no big deal. You just go 6 squared plus 8 squared is blank squared. And then once that's a 10, you know that's a 10. What's the perimeter? 32. And you will definitely see a question like that on your quiz tomorrow, because we did one like that the other day. Okay, I'm just going to jump. Let's go to page 12. And let's do the 4 I wanted to do on page 12. So let's start with, well, let's just look at 10 real quick, just because sometimes students have a problem knowing what the base and the height are. So starting with number 10, what shape are we looking at? A triangle. What's the formula again? Base times height over 2, or 1/2 base times height. Can you tell me what the base and the height are?
12 and 16.
Good, 12 and 16. So I just didn't know if everybody heard me a minute ago, but wherever the right angle is, the base and the height are always attached to that. So it really doesn't matter which one's the base and which one's the height. It'll just be 12 times 16 over 2. So this one turns out to be really easy. I just wanted to make sure that you guys knew. 96. Centimeters squared, if I wanted to give it a label, but I don't really care about that. Okay, let's look at 12. Number 12. What shape? A parallelogram. Top and bottom are parallel, left and right side are parallel. So what's your formula for area of a parallelogram?
That one.
What's that one?
A equals H times B1.
Not that one. That's a trapezoid one.
Okay.
Base times height.
You were right.
Now, if I were to cover that up, I would have a trapezoid.
Indeed.
But as soon as I reveal that, I've got a parallelogram. Top and bottom parallel, sides are parallel. Okay, can you tell me right now what the base is?
12.
The base is 12. If this top piece is 12, this bottom piece is also a 12. So that is the base, and this will be the height attached to it. It's just the height that we don't know right now. So the base is a 12, and we're about to find the height. Okay, what kind of triangle do we have going on?
30, 60, 90.
30, 60, 90. And what goes across from the 30? X. Now that's just this piece. What goes across from the 60? X square root of 3. And what goes across from the 90? 2x. Remember, if there's a label there, put an equals between it and the 2x. Okay, take a second, find my x, find this piece, and then we'll talk about it.
I
Oh.
got the areas.
Okay, what's your x?
4.
4. So what is he down here?
4.
4. And what's the height?
4.
4 square root of 3. You just put the 4 in the x, recopy the square root of 3. Okay, once you know the height is 4 square root of 3, all you're going to multiply are the 12 and the 4. What's 12 times 4? 48, recopy the square root of 3. So simplest radical form isn't that awful. It just depends on the problem. Sometimes they're awful, sometimes they're not. Quite honestly, I don't remember if there's one like that one on the quiz, but I know that you definitely have a 30, 60, 90 on there. Okay, let's do 14. I can guarantee that there's a picture like 14 on there. Do you know what 14 is? It's a rhombus. And the reason it's a rhombus, not a kite, is because all 4 sides are congruent. So this is a rhombus. Now, if you thought it was a kite, it wouldn't harm you because they use the same formula and they both have 90-degree angles in the center. So if you thought it was a kite, it really wouldn't matter. Okay, what's our formula for area of a rhombus?
D1 times D2 divided by 2.
Okay, D1 times D2 divided by 2. Do we happen to know any of the diagonals? No, so we got to work on it. So I am going to color this guy right here in green. I know it's a right triangle, and specifically, I know it is a 30, 60, 90 triangle. Do you feel like you need me to blow him up off to the side to work him a little bit better? Does anybody want me to? No? You do? Okay, I'm going to do it. I'm just going to blow him up over here. This was the 60, that's the 90, that's the 30, and we know this one. What's this one?
6.
Okay, so I'm just working it just a little bit bigger. Okay, so here comes the labels. What goes across from the 30? What goes across from the 60? X squared 3. And what goes across from the 90? 2x. So 6 equals 2x. What's x? 3. Divide both sides by 2 and you get x is 3. Okay, so if x is 3, what is this piece right here? 3 square root of 3. So that's this guy right there. 3 square root of 3. And then what's this one? 3. So if that's a 3, then this guy right here is a 3. Okay, we now know what we need to know. If this is a 3, what's this one?
3.
How long is this diagonal? 6. Okay, so one diagonal, 6. If this is 3 square root of 3, what's this one? 3 square root of 3. And how long would this whole diagonal be? 6 square root of 3. 3 square root of 3 plus 3 square root of 3 is 6 square root of 3. I'm going to recopy the over 2. Now we're going to ignore Mr. Square root of 3. What's 6 times 6 divided by 2? 18, right? 6 times 6 divided by 2 is 18. So it's 18 square root of 3 in simplest radical form. So I can guarantee you're going to see one like him. Okay, let's go to 16. And then I'm going to have you try 3 for me while you have time in class, and I can try to hop around and help you. I probably won't hop, though. Okay, 16. What shape? Trapezoid. So this is the one that we do height times base 1 plus base 2 all over 2. Okay.
It's a 30, 60, 90.
It is a 30, 60, 90. I am going to drop down this altitude, which represents the height of the shape. It makes a 90-degree angle with the base. It is a 30, 60, 90. Okay, what goes across from the 30?
X.
X. So just from here to here is X. Okay, what goes across from the 60? X square root of 3. And what goes across from the 90? 2x. So since there's an 8 there, I'm going to put an equals between it and the 2x. Man, I'm so tired of seeing 2x equals 8. What do you get?
4.
4. So if you divide both sides by 2, you get 4. So what is this little piece down here?
That's 4.
4. And what's the height of the shape? 4 square root of 3. Now there's one other thing. Uh-oh, I want a different color. What is he? What'd you say, Jonathan? It's 11.
Indeed.
Before I started writing on this problem, wasn't this whole thing a 15?
Mm-hmm.
If it was 15 from here to here, and we just found that to be a 4, does it make sense that this one needs to be 11? That way the 11 and the 4 makes the whole thing, which is 15? Okay. So I'm ready to plug everything in. So what's my height? 4 square root of 3, what's base 1? 11 plus, what's base 2? 15. That's what it was before I started messing with things. And then I'm just going to recopy the all over 2. Okay, at this point, I can go ahead and I can add the 11 and the 15. What do you get if you add the 11 and the 15? So I got 4 square root of 3 times 26. I recopy the all over 2. So I'm just ignoring this square root of 3. I'm going to cover them up with my pen. We want to take 4 times 26 and divide by 2. So 4 times 26 and divide by 2. Ignoring Mr. Square root of 3. 52. And then you just put the square root of 3 back on. And there he is. And that's your answer. Feeling better? Well, I'm going to give you 3 to try while you still have plenty of time to do them. So I'm going to have you try 15, 17, and 18. And I'm just having you do area, not perimeter, so just area. So 15, 17, and 18. Try those 3. You guys still have like 15 minutes in the class. So 5 minutes per problem ought to be enough. And I can come around and I can assist you. And then tomorrow we'll go over those 3 if we don't have time today. And then we'll have our quiz.
What are those triangles you told us about? The 54, 3, 4, 5.
Oh, I told you about a 3, 4, 5, a 6, 8, 10, a 9, 12, 15. All of those just are based off of the 3, 4, 5 triangle. Like if you multiplied the 3, 4, 5 times 2, you get the 6, 8, 10. If you took the 3, 4, 5 times 3, you get the 9, 12, 15. And then yesterday, we came across... There's a bunch of them. I don't know where that other one was. We had another one yesterday that came out real nice. But those 3 are the ones that you see the most out of everything. I guess another one that we saw the other day was a 8, 15, 17. I don't know. There's a bunch of them.